My name is Lance Akiyama. I'm the author of Rubber Band Engineer, and I'm going to show you how to build one of the projects for my book, the Hydraulic Fighting Robots. Cut 4 cubes from the square dowel with the saw, and then, with a pair of pliers, hold the cube and drill a hole that's slightly larger than 1/4 inch. Drill holes like this into all 4 cubes. Next, gather 4 craft sticks, bundle them together, and then drill an 1/8 hole through all of them. Time to start building the hydraulic fighting robot foundation, which consists of the base, the pivot column, and the fighting arm stem. These pieces are what allow the hydraulic fighting robot to move from side to side and up and down. The base starts with 3 craft sticks in an H shape, the cube, and the dowel. Build the pivot column by gluing 2 cubes onto a craft stick, making sure that the holes are aligned. Stop here and make sure that it fits on the dowel and turns smoothly before continuing. Wrapping tape around the top of the dowel prevents the pivot column from sliding off during combat. Begin creating the hinge for the fighting arm stem by gluing on 2 craft sticks with holes as shown. Make sure that the holes are aligned with each other. The fighting arm stem is created by gluing 4 sticks together into a box shape, using the 2 other sticks with holes. Insert a skewer through all 4 craft sticks to create a hinge for the fighting arm stem. The last piece for the foundation is the hydraulic connector, which attaches to the bottom of the pivot column. This is where one of the hydraulic systems will attach. Make sure that the hydraulic connector doesn't interfere with the pivot column's ability to rotate. And that's it. It's up to you to build the last 2 parts, which are the base and the fighting arm. The base must fit within a 12 by 12 inch square, otherwise you could build a giant sprawling base that's impossible to beat, which isn't very fun. Generally, you want to make the base wide and rigid. There are 2 other parts of the base that you'll want to include, one of which is the pivot column support. These craft sticks and cubes prevent the pivot column from bending or breaking during combat. You don't have to build yours exactly like this, but you should support it in some way. The other thing that you need is friction. Add beads of hot glue to the bottom of the base. This will prevent the robot from being pushed around too easily. Next is the fighting arm. You'll want to make it long enough to at least reach your opponent's base, but the length is up to you. However, don't make it too long or else you may reach past your opponent's pivot column, which will make it difficult for you to get any leverage. Regardless of the length, the most important thing is that the fighting arm is rigid. You don't want it to bend or break during combat. The tip of the fighting arm is what will come into contact with your opponent most often, so the way you design it is very important. This example uses a thin triangular wedge that rests flat against the ground. It's specifically designed to get under the opponent's base and flip them over. Time to make the hydraulic systems. Begin by drilling an 1/8 hole through the syringe plunger. Fill up 1 syringe with water, attach the tubing, and then push water through the tubing to remove all of the air. Fill it back up to 10 milliliters, attach the other syringe, and try it out. It's important that the hydraulic system has little to no air in it. If you have air in the system, your pushes and pulls on the control will expand and contract the air instead of pushing and pulling on the water. Insert a cable tie through the plunger and then tie it onto the fighting arm. Keep it a little bit loose. If it's too tight, it won't work. Fill the syringe with 2 milliliters of water and then strap it tightly to the pivot column with duct tape. Test it out! Your fighting arm should be able to touch the table and reach high into the air. Attaching the hydraulic system to the pivot column is a little trickier, but it starts in the same way. Tie the plunger to the hydraulic connector and, like before, keep it a little bit loose. Fill the syringe halfway with water and point the fighting arm straight forward. Hold the syringe in place and try it out. The fighting arm should move side to side in equal amount. Strap the syringe to the base with another piece of duct tape. Since all bases will be built differently, you may need to get creative with how you attach the hydraulic system to the pivot column. Give it a test and make sure that your fighting robot has a full range of movement like this one. Test out its strength as well. You can see that the hydraulic systems are very effective at transferring energy from my hands to the fighting arm. Here's another example of a different fighting hydraulic robot design. This one has most of the weight of the base toward the front, which means that when the fighting arm raises, the whole robot tilts forward with the goal of pushing the opponent rather than flipping. The tip of the fighting arm is also designed to focus on pushing. Get ready for battle. Place both robots on a table facing each other with the fighting arms pointing straight up in a 3-inch gap between them. 3, 2, 1, go! You can win by pushing your opponent off of the table or by flipping them over in such a way that they can't right themselves. It's also possible to win if your opponent flips themselves off of the table. If neither robot can effectively reach the other, then the players can agree to a stalemate and restart. That's everything that you need to know to make your own hydraulic fighting robot. If you like this project, then grab a copy of Rubber Band Engineer. It's full of other unique projects that are built using household hardware, including some others that are powered by hydraulics. Thanks for watching, and have fun building!